Hi everyone, this is an introduction video into the new digital technology curriculum focusing on introducing the keyword coding in a year 0 to 2 classroom. So basically we're going to look at what is the new digital technologies curriculum all about. Well, the aims and the goals of the curriculum is to help all learners to be digitally capable and to be able to use and create digital technologies to solve problems, take advantage of opportunities, and it's not actually all about the term coding. I know that terminology has been thrown around a lot with the increase of ICT in a classroom and the digital technologies curriculum, but there is more to it than that. If you have not yet read or seen the digital technologies curriculum, there is a link there at the bottom that you can click on and have a look at that. So this is where it fits into the current technology strand within the New Zealand curriculum. On this side there we have got the 3 strands that currently exist already, and then we have the new addition of the 2 new areas, which is computational thinking for digital technologies and designing and developing digital outcomes. And for these 2 we actually have something called progress outcomes used. It's not using achievement objectives. So if we were to look in the digital technologies curriculum, it would come up with these 2 lovely long explanations on what they mean. Computational thinking for digital technologies is there on the left, and designing and developing digital outcomes on the right. And when I look at this, I get confused by all the big fancy words that are there and really don't understand what they mean. So in this video, we're just going to look at computational thinking for digital technologies and how can we unpack that for it to make sense to us in a classroom. So in a year 0 to 2 class, you would be working at progress outcome 1, which is there in the red circle. As the year levels go on, they move down into the different levels of the curriculum, progress outcome 2, etc., etc. And for progress outcome 1, basically it's asking for students to, in authentic contexts and taking account of end users, students use their decomposition skills to break down simple, non-computerized tasks into precise, unambiguous step-by-step instructions, algorithmic thinking. They give these instructions, identify any errors in them as they are followed, and correct them, simple debugging. Well, still, for me, I'm a pretty straight up teacher. I like everything laid out in plain black and white. That does not make any sense to me still. So let's unpack that with some keywords. So basically the first keyword I took away from that is authentic context. That would be things that are relatable and relevant for your kids to solve. Simple non-computerized tasks, so not using digital devices. That's what that part is meaning. So being able to work through an activity on paper and pen first before giving them a digital device to solve it. Step-by-step instructions. Basically, that's a really fancy way of saying an algorithm or algorithmic thinking. So when you'd say, let's go and solve some instructions for putting on our shoes, you could say, let's do an algorithm for putting on our shoes. And the kids will be so wow that you're using this big fancy word. The last keyword in this progress outcome is identify any errors. So a algorithmic or coding terminology for that is called debugging. So that's where you are looking for any errors in the instructions and you would debug, which would mean to take them out. So if we look at an example for a year 0 to 2 class, it would look like this. Using keywords such as left, right, up or down to get an object, so in this one the bee, to the hive by going past some pollen or flowers as you go. And so the students would write the instructions down on a piece of paper, thinking about how they get the bee to the hive. So for example, if I was the bee, I might write up, 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 right. Okay, then you write the first one. Then you might go right, right, down, down. And so students are just simply working through a problem like this. Obviously it could be different themes, different objects, different activities for something to be solved. and then you can give it to a buddy for them to check and to see if there's any bugs. And obviously if there are, they could debug that and try again. So hopefully that's not too hard for your students. It could be linked into an example for any learning area. Maths definitely fits into directions, science, inquiry. Again, like I said, this could be a little person and you're trying to collect different objects linked into a theme or a topic that you're studying. Have fun with it. Students can write the instructions on a whiteboard. You could have it in a buddy activity. Anyway, that suits your class. The key terminology, remember, you want to try and use the word algorithm, which means steps of instructions, and debugging, which is if there's a problem, you fix what went wrong in your instructions. And those two words summarize a very simplified coding for students in a Year 0 to 2 classroom. Some things to help you in your lessons. We've got a link there to the Digital Technologies curriculum again, just in case you'd like to spend some time flicking through it and having a look. There are some exemplars there from the Digital Technologies curriculum. We've got a very simple long-term plan for coding with some basics to get you started and some computational thinking for digital technologies examples as well there. And just a reminder that students don't need to code on devices yet unless they have the terminology and concepts down packed. Hope that gives you a few ideas around teaching computational thinking for digital technologies in a Year 0 to 2 classroom. Thanks!